In the last couple of videos we have defined what an atom is and its fundamental particles, and we also have seen the concept of an isotope. Now, when atoms of a particular element combine, you generate something that is called a molecule. Okay, so for example, we have seen how an atom of carbon is, and when this atom of carbon combines with a different atom of an atom of a different element, you might have something that we call a compound. For example, CO, carbon monoxide, or perhaps CO2, carbon dioxide. And now something important in molecules is that is the way that those atoms interact to form the molecule. Okay? In molecules like this, what we actually have is that the atoms of carbon and oxygen share the electrons, okay, to form something that is called a covalent bond. Okay? And that is the only thing that we need to know just for now. That a covalent bond is just the sharing of electrons between two different atoms. Okay? And that gives rise to an interaction that holds the atom together to form a molecule. Right, now we will devote quite a bit of time to actually explain to a great level of detail what a covalent bond is, but that will happen much later on. Okay? Now there's various ways to denote molecules. We actually have here something that is called the chemical formula, which simply tells you what elements that a molecule contains and how many atoms you actually have of each element. Okay, so that is what we call, again, the chemical formula. But there are other types of formulas that are a little bit more informative. For example, we have structural formulas that actually tell you how those atoms are connected. Right? So for example, if we actually simply write CO2 without any further understanding of how the chemistry of CO2 carbon dioxide is, we might infer that maybe the way that these atoms are connected is COO. But we actually know that that is not true. Okay, we actually know that CO2 in reality is a molecule and the connection is like this. Okay, so this will be the chemical formula, but notice that there's no information about the connectivity of the atoms. It simply tells you how many atoms you have of each type. Okay, this is what we call the structural formula that gives you a little bit more about the connectivity between the atoms. Now this also might be inadequate because we're actually not saying anything about the shape of the molecule with the structural formula. Okay, so there are other ways that we can actually start to think about what the shape of that molecule will be. For example, if we think about water, okay, H2O, okay, and we write the structural formula like this, okay, we know then that the origin of the atoms is like this. So you have two hydrogen atoms connected to that oxygen atom. But we can actually go a little bit further and actually write it like this, because we know that the bonds in water are actually not in a linear arrangement, they're in a band arrangement. Okay, so again, there's ways to increase the level of description of the molecule, and we will see those later on as well. But for now, suffice it to say that generally we're simply going to be using either the chemical formula and the structural formula as well, if we need to know information about how those atoms are connected. Okay, so that is the definition of a molecule. Now, we're going to move on and talk also about ions. Okay, so until now, every single atom that we have discussed was neutral. Okay, so there was the same number of electrons and the same number of protons in the atom and in the molecule. This molecule is neutral as well because overall it has the same number of electrons than protons. Okay, all right. The question is, well, what happens when you actually have an uneven balance between protons and electrons? Okay, well, when that happens, you actually form something that is called an ion. Okay, so for example, take an atom of sodium, which is going to be 1123. Okay, and then what we're going to do here is remove an electron to generate this ion. Okay, so what has happened here? Well, if we take a look at the atomic symbol here, that is sodium. It has 11 protons, and then it will have 23 minus 11, that is 12 neutrons. Okay, that has no charge, so that means that you have 11 electrons. Okay, but if we remove one electron, what happens is that, well, now you have a positive charge. The number of protons hasn't changed. We haven't touched the protons. We only have removed one electron. The number of neutrons hasn't changed either. You still have 12. Okay, so that part hasn't changed. The only thing that has changed is the number of electrons. Now you have one fewer electron. Okay, and that is where you have a positive charge right here. Okay, so that will be 10 electrons, 11 protons, and then 12 neutrons. Okay, there is the formation of a positive ion. The same thing we can do with other elements. You can actually form negative ions. Okay, for example, chlorine. If I use, say, chlorine 17, 35, okay, this is going to be chlorine. In this case, I'm actually going to add here an electron. And then what will happen is that you still have the same number of protons, same number of neutrons. Okay, but the difference is that now you have a negative charge. Okay? Right, again, what you have done right here is add one electron to this atom. Notice that it had 17 protons to start with, 17 electrons, the charge was 0, neutral. Okay, now you have one electron, so you will have that this atom now has 17 protons and 18 electrons. Okay, and that generates a negative ion. A little bit about the language. So positive ions are called cations, and negative ions are called anions. Okay, now when you have ions, okay, it turns out that these ions can interact with each other, okay, to form compounds. Okay, so for example, if we get the interaction of a sodium plus ion with a chloride minus an ion, we actually will generate something that is called sodium chloride. Okay, now something is very important about this solid right here. Okay, that will be a solid, and the important thing is that the interaction between those two species is actually what we call an ionic bond. Okay, so this structure is held together because there's electrostatic interactions between the positive and the negative ion. That will be the dominant interaction between those two species. Okay, and that is what we call an ionic bond. Now that is fundamentally different from the case of Cl, where actually this is an interaction between two atoms that are not charged. And again, we've said that we call that a covalent bond, and the interaction is done through the sharing of electrons. In this case, there's no sharing of electrons. There's simply something that we call an electrostatic interaction. Positive attracts negative, and that holds the molecule, the species together. Okay, so I will actually take some more time to define very, very carefully what an ionic bond is and what a covalent bond is. But for us, we're just trying to introduce, for now, we're just trying to introduce here useful concepts that will be used in just the next few videos.